Hi. So far we have discussed about infinite series, their convergence, various convergence tests, and also alternating series and absolute convergence and everything. So in this session we will be discussing an infinite series, at a particular type of infinite series which will have variable terms, okay, not constant terms. For example, we have discussed about series like 1 plus 1 by 2 plus 1 by 3 plus 1 by 4, etc. So we can see that in this series the terms are constants, but we will now be focusing on series which will have terms like this: 1 plus x by 2 plus x by 2 the whole square plus etc. like that. So basically we will be focusing on series which will have variable terms. Okay, so that is what we are going to discuss there. So what the problem here of convergence is that here the convergence of the series will depend upon the value of this x. Okay, so the convergence, so if the f has a value, x has value 1, this will be like 1 plus 1 by 2 plus 1 by 2 the whole square plus etc. Or if the x has the value 2, it will be like 1 plus 2 by 2 plus 2 by 2 the whole square plus etc. So this can be convergent or not. This can be, so basically the convergence of these series will depend upon the value of x. Okay, so we will be focusing on such series in this session. In particular, we will be focusing on two special series called Taylor series and also Maclaurin series. Both will have variable terms here. Okay, so remember one thing: the convergence of these series, these variable term series, will depend upon the value of x. So basically when you talk of convergence, we will take condition on x. Okay, so it will say that if the x has this condition, or the x is lying in this value, it will be convergent, or if the x has this value, it will be convergent. So we can't say whether this series is convergent or not right away. We will have to say a condition on x. Sometimes it may be convergent, it may not be convergent, so some condition will be lying which depends upon the value of x. So we will be discussing that, but remember we will be focusing here on variable term series. Okay, so for example, if you know that this series, you know that 1 plus x square plus x cube is equal to 1 by, so already this is, you know, this is a geometric series which we have studied in the beginning of infinite series, since x is being multiplied here. So since this is a geometric series, its sum is actually 1 by 1 minus x, and you know that the sum will exist if mod x is less than 1. So the condition here is actually that x should be lying between minus 1 to 1. So minus 1 less than x less than 1. So this is the condition here. Okay, so these type of conditions and all we will be discussing here in this session. Okay, so this convergence will depend upon the value of x. Okay, so here basically we are going to study about power series. Okay, so what do you mean by power series? So power series is basically an extension of the familiar polynomials. For example, if you know the polynomials, it is actually 1 plus 2x plus 3x square is a polynomial, or we can say that 2 minus 3x is again a polynomial, 2 is a polynomial. So basically, you know what do you mean by polynomials. Okay, now power series is an extension of these polynomials, means it is actually there will be infinite terms in this expression there. For example, it will be like this: it can be 1 plus 2x plus 3x square plus 4x cube etc. It will be going on increasing like this. So basically power series is basically an infinite extension of the polynomials. Okay, so if how will I represent power series? Very simple. I can write this as simply some a naught plus a1x plus a2x square, okay, plus etc. plus an x raised to n plus etc. So this is the basically the general form of a power series, or I will simply write this in k is equal to 0 to infinity a k x raised to k. So this is the general form of a power series. So what is a power series? So this is just for your understanding. Power series is basically an infinite extension of the familiar polynomial. So it will be like this only: 1 plus 2x plus 3x square, or it can be like 1 plus 1 by 2x plus 1 by 2 square x square. So it can be like this. So it's an extension of the familiar polynomials. So we'll be focusing particularly on power series in this session. Not every variable term series we will not be discussing, only the power series terms we will be discussing, because the power series has some very interesting properties. Okay, so for example, if you look at this series here, that is, if you just focus on a naught plus a1x plus a2x square plus etc. plus maybe a k x raised to k plus etc. Okay, can you give me a value of x for which the series converges, or for the value of x for which the series has a definite value? Can you give me the value of x? Okay, so this series can have different values for different x. For example, if the value of x is 1, the series will be like a naught plus a1 plus a2 plus etc. plus ak plus etc. So the convergence will definitely depend upon the values of this a1, a2 and a naught, a1, a2 etc. Okay, if the value of x is 1, x is 2, I will be getting a different series which is a0 plus a1 into 2 plus a2 into 4 plus 2 square plus etc. plus ak into 2 raised to k plus etc. So we will have to discuss the various tests there, comparison test or ratio test or power series test etc. to discuss the convergence of this. Okay, so when you substitute the value of x, you will be getting different infinite series and you will have to look at their convergence. But there is a definite value of x for which the series is always convergent. Okay, can you guess that value? There is always a definite value of x for which this series will always be convergent. Can you just guess it? Yes. So it is nothing but if you put x is equal to 0, what will you get? If you put x is equal to 0, all other terms would become 0. You will be just getting this term as a naught. So this series will definitely be convergent for x is equal to 0. Okay. But for x is equal to 1, I cannot be so definite because it depends upon the values of this a naught, a1, a2. Similarly for 2 also, it depends upon the values of a naught, a1, 2, a2, x square, etc. Okay, so this power series is always, this power series a0 plus a1x plus a2x square plus etc. is always convergent for the value x is equal to 0. That is one observation. Okay, and there is one important result also is that this power series or any power series for that matter will converge around an interval around this x is equal to 0. Okay, so this power series will always converge. So there is a very interesting result which states that this power series always converges in an interval around x is equal to 0 and will diverge outside. What does that mean? It's nothing but suppose you are just plotting the x values here. Here actually the power series is converging at x is equal to 0. Now all the points of its convergence will always lie in an interval around x is equal to 0 only. Okay, so it will always be convergent around this interval. At all points outside this interval, it will be divergent. So that is the main property of this power series. Okay, so I hope it is clear. So power series is always convergent at x is equal to 0, and if you want to find the other points of convergence, you can always, there is a result that it will always converge at all points around this point x is equal to 0 only. Okay, so this x is equal to 0 will be the center of that interval. So we will say that this is the center of that interval, and this is the actually the this interval is called the interval of convergence. Okay, this interval is called the interval of convergence. The proof is not required for you. Actually, all this is not required for your examination. This is just for your understanding. I am telling you. Okay, so this is the main. So apart from a general variable term series, for a general variable term series, it may not be the case. For general variable term series, maybe the series will converge for x is equal to 0, maybe it will be diverging for x is equal to 1, and maybe it is converging for, so it will be scattered around like this. So it may be convergent at this point, it may be divergent at this point, it may be convergent again at this point. So for a general variable terms series, it will not obey the rules like a power series, so it will be random. But for a power series, the convergence point, so the values of x for which the series convergence will always lie in an interval around x is equal to 0. That's the main property of power series. This is just for understanding, and therefore when you talk of power series, you will always talk of an interval of convergence. Okay, because an interval of convergence which will be centered around this point x is equal to 0. Okay, and similarly we can also talk of the radius of convergence. What do you mean by radius of convergence? It's basically the radius of this interval. Okay, so this length. So this length is r, and this length also will be r. Okay, so this length, half length, is called the radius of convergence. So this is the main property of power series. So we will be discussing about a particular power series here. So that is Taylor series and also Maclaurin series. Both are very easy, but before we discuss Taylor series and Maclaurin series, it is very important that you understand what do you mean by power series. A power series is basically a series which has powers of x. Okay, it will be like a0 of some constant plus a1 into x plus a2 into x square plus ak into x raised to k plus etc. So you are getting a series as powers of x. That is why it is called a power series. Okay, and this power series always converges at x is equal to 0 on condition. Okay, and moreover its convergence will always be in an interval around x is equal to 0 with x is equal to 0 as the center. Okay, at all points away from this, at all points outside this interval, the power series will definitely be divergent. So when we talk of power series, you can always find a interval of convergence, and also we can talk of the radius of convergence also. Okay, and one more point I would like to make here is that this is just for information. At the end points of this interval, we can't conclude anything. Sometimes some power series may converge at the end points, or some power series may converge at this endpoint, it may diverge at this endpoint. Okay, so we can't say for sure. At the endpoints, we can't say whether the power series is divergent or not, but away from the intervals, it is divergent. Inside the interval, it is convergent. Okay, so these are some takeaways of our discussion in power series. Okay, so what is a power series? So power series is basically an infinite series which has powers of x. Okay, that is the idea. Okay, I hope it is clear. Okay, so now we'll extend this concept of power series to a, so this is basically, so we'll call this power series as a power series about x is equal to 0. Okay, we'll say that this is a power series about x is equal to 0. Why am I saying that? Because here the powers are actually x, x square, etc. And as we talked of the convergence, you can see that the convergence is always around a point x is equal to 0 only, with x is equal to 0 as center and then interval around this x is equal to 0 with center at x is equal to 0. Okay, so basically this power series converges around this point x is equal to 0. So we will say that this is the form of a power series about x is equal to a. Okay, that is one idea. Okay, now we can extend this concept of power series to a point x is equal to a. So I will talk of a power series about x is equal to a. In that case, your power series will have terms involving x is equal to a, or in other words, your terms would be like powers of x minus a. Okay, or if I write it, it will be like this only: a0 plus a1 into, instead of x I will have x minus a. Okay, so that is why here the powers are in terms of x is equal to a. So it is a1 into x minus a plus a2 into x minus a the whole square plus etc. Okay, so this is a power series about x is equal to a, and if you look closely, can you tell me a point of definite convergence of this power series? If you take x is equal to a, what will you get? If you take x is equal to a, all these terms will become 0 and you will be just getting fixed term as a naught. So always this power series is convergent at the point x is equal to a. That is one idea. Okay, and then as I told you, in the case of x is equal to 0, here also the convergence would be around the point x is equal to a as a center. Okay, so always in an interval around x is equal to a. So you can talk of the interval of convergence and also the radius of convergence also here. Okay, so that is the idea of power series. So when I tell you about power series, remember it is either in powers of x, or it will be given. So sometimes they will ask you expand this function as a power series about x is equal to 0. So the question will be like this: expand this function as a power series about x is equal to 0, or expand this function as a Taylor series about x is equal to 0. That means you need to expand the function in powers of x. Okay, so and sometimes the question will be expand this function as a power series about x is equal to 2. That means you have to write the function as an infinite series containing the powers x minus 2, x minus 2 the whole square, x minus 2 the whole cube plus etc. So this is the idea. Okay, so when they are asking you to expand the function powers of x, means your infinite series should contain x, x square, x cube etc. Okay, if they are asking you to expand the function in powers of x is equal to 1, it means you have to expand to contain terms like x minus 1 the whole square, x minus 1 the whole cube plus etc. So this is the idea of power series. Okay, I hope it is clear. Okay, so this is general form here. So as I told you, at the endpoints it may or may not converge. Okay, now we will discuss two particular power series, which is Taylor series and Maclaurin series. Okay, so what is Taylor series and Maclaurin series? It's very simple. Sometimes you have, suppose you have a function called f of x which has all the derivatives. That is, suppose it has derivatives f dash x, f double. So it has derivatives of all orders. Okay, for example, f dash of x, f double dash of x, f triple dash of x, etc. So suppose you can find all the derivatives. For example, e raised to x or sin x or cos x. Okay, so we can say that these functions have every derivative there. Okay, suppose you have a function which has derivatives of all orders, then this function can be expanded as a power series. Okay, so the power series will be like this. So suppose this function can be expanded as a power series about x is equal to a. So how we'll expand it? It will be like a0 plus a1 into x minus a plus, okay, plus a2 into x minus a the whole square plus etc. plus ak into x minus a the whole raised to k plus etc. So you can see that this is actually a power series about x is equal to a. Now for Taylor series, this a0, a1, a2 will have a definite value. So I am going to discuss this, I am going to write down that value. But before that, remember that Taylor series says that a function which is infinitely differentiable can be expanded as a power series about x is equal to a. Okay, so if you know the concept of power series, it will be like this only: a0 plus a1 into x minus a plus a2 into x minus a whole square plus etc. So they will be asking you, the question will be like expand e raised to x as a power series about x is equal to 0 or x is equal to 1. That means you have to write e raised to x as some constant into a1 into x minus 1 plus a2 into x minus 1 the whole square plus etc. Okay, now what is this a naughts and a1s? So the Taylor series gives a formula for this a naughts. It says that your ak is equal to fk of a by k factorial. Okay, that means I'll write it down. Your a naught is nothing but f of a plus a1 is f dash of a by 1 factorial. Okay, your a2 is plus f double dash of a by 2 factorial into x minus a whole square. Your a3 is actually plus f triple dash of a by 3 factorial into x minus a whole raised to k plus etc. plus what is your ak now? Can you just guess? If it is fk of a by k factorial into x minus a raised to k plus etc. So your ak is nothing but fk of a by k factorial. Okay, so this is what you mean by a. So this is the Taylor series expansion. Okay, so suppose I am giving you a problem, expand e raised to x as a Taylor series about x is equal to 1. What you have to do? Just write down this formula and substitute the values. Okay, so what will you do? Suppose I need to expand this as a Taylor series about x is equal to a 1. What will I do? So it will be f of a. F of a means this is your f of x. So f of a means e raised to 1. So it is just e. Plus what is f dash of a? F dash of a is first you find f dash of x. Okay, this is your f of x. F dash of x is again e raised to x. So f dash of a is e raised to 1. So it will be e raised to e by 1 factorial into x minus 1. Okay, plus again f double dash of a will again be e by 2 factorial into e by, sorry, just a second. Okay, so e by 2 factorial into x minus 1 the whole square. Okay, so this is the way you have to write. So you will be given, so this is the formula for Taylor series. What is it? Nothing but Taylor series basically says that f of x can be expanded as a power series about x is equal to a, and it actually gives the value of that power series. What is it? It is nothing but f of a plus f dash of a by 1 factorial into x minus a plus f double dash of a by 2 factorial x minus a whole square plus etc. So this is the idea. Okay, so so the problems will be, you will be given a function and you will be asked to find the Taylor series. That's it, nothing more. Okay, and what do you mean by Maclaurin series? And Maclaurin series is actually a special case of this Taylor series where your value of a is 0. Okay, so that means where the value of x is actually 0. So the expansion of Maclaurin series, can you guess it? It is nothing but it's a special case of the Taylor series. So it will be, instead of a you will have 0. So it will be f of x is equal to f of 0 plus f dash of 0 by 1 factorial into x plus f double dash of 0 by 2 factorial into x square plus etc. So usually the question will be only about Maclaurin series. Sometimes they can also ask questions about Taylor series also. Okay, so I hope it is clear what do you mean by Taylor series and Maclaurin series. We will do some problems and then you will understand this expansion. Okay, so this is the expansion here. The Taylor series is f of x0 plus f dash of x0 into x minus x naught plus f double dash of x0 into x minus by 2 factorial into x minus x naught the whole square plus etc. And similarly, the Maclaurin is a special case where your x naught is actually 0. So it is f of 0. So here it is a power series about x is equal to x naught. Here it is a power series about x is equal to 0. So these are the cases. Now what is the significance of this Taylor series and Maclaurin series? Okay, so basically you are expanding the function f of x as an infinite series here. Okay, so if you guess, if you think geometrically, suppose this is your point x naught. Okay, so suppose this is the value x. Okay, you know all the properties of the function at the value x naught. Suppose you know all the properties of the function at the value x naught. You need to find the value of the function at f of x. Suppose you need to find the derivative, whatever you need. So you need to predict or find the value of the function at f of x. What will you do? Okay, just apply the Maclaurin series, just apply the Taylor series here. So if you look at the right hand side of the series, you can see that here we are using only the properties of the function at x naught only. Okay, so here you are using f of x naught is there, f dash of x naught is there, f double dash of x naught is there, and this term is actually the distance between these two terms, x minus x naught. Okay, so basically this actually denotes the distance between these two terms, and similar this also denote the distance between these two terms. So you can say that just by using the information at a point x naught, you can predict the values at the point x. Okay, so basically this Taylor series and even Maclaurin series is used for predicting the values of f at near points. Okay, so that's why it's widely used in numerical analysis and also differential equations and everything. Okay, because you can predict the values of the functions at the value of the values at nearby points. So if you look at for example in experiments and everything, you won't be taking the values at every point. Okay, so when you're taking the values of the points, so basically if you look at laboratory experiments and everything, you'll be actually taking the readings at fixed time intervals. Okay, so maybe 0 seconds, 5 seconds, 10 seconds, etc. But with that data itself, you can always predict the value at the point 1. Okay, at 1 second, 2 second, 3 second, because if you use this formula, you can always predict. If you know the information at 0 seconds, you can predict the information at 1 second. Similarly, if you know the information at 5 seconds, you can predict the information at 2 seconds. So basically, for predicting the values of the functions, this Taylor series and Maclaurin series are extensively used. That is the application of these series. Okay, now let us do some problems where we will be trying to find out the Maclaurin series and Taylor series and everything. So usually simple problems will be asked for you. Let us try to do some problems here. Okay, so look at this function e raised to x. Okay, so let us find the Maclaurin series. So please write on the Maclaurin series now itself. Try to study it now itself. What is it? It is f of x is equal to f of 0 plus x into f dash of 0. Okay, plus x square by 2 factorial into f double dash of 0. Okay, plus x cube by 3 factorial into f triple dash of 0 plus etc. Okay, so when you are being asked to expand this Maclaurin series or Taylor series, just try to write down this expansion first and write a first few 1 or 3 or 4 terms. Okay, maximum 3 or 4 terms depending upon the marks. That's enough. Okay, so this is what we are going to do here. Now let us try to find the Maclaurin series of e raised to x. So this is the Maclaurin series, so you have to substitute it here. So you have f of x is there, which is e raised to x. So I am going to substitute it here. So what is your f of 0? F of 0 is e raised to 0, which is 1. Okay, please write down with me, only then you will understand. And next in the expansion you have x is there, already you know the value of x. And what is f dash of 0? First you need to find f dash of x. What is f dash of x? It is e raised to x. So what is f dash of 0? It is e raised to 0, okay, equal to 1. So prepare a table like this in your paper. Okay, similarly my next substitution would be f double dash of 0. So for that I need to find f double dash of x. F double dash of x is e raised to x. What is f double dash of 0? F double dash of 0 is e raised to 0, which is again 1. Okay, similarly what is f triple dash of x? It is again e raised to x. So what is f triple dash of 0? It is again e raised to 0, which is 1. Okay, now I am going to write down the expansion. So what is f of x? Your f of x is actually e raised to x. It is equal to, what is f of 0? 1 plus, okay, x into, what is f dash of 0 again? F dash of 0 is again 1 plus again x square by 2 factorial into, what is f double dash of 0? F double dash of 0 is 1 plus again f triple dash of 0 is again 1. So it is x cube by 3 factorial plus etc. So this is actually the Maclaurin series expansion of e raised to x. So it's very important expansion. Try to remember it by heart. We will be using this in problems also. So this is a very important expansion. Okay. Similarly, I am giving you homework. Try to find the Maclaurin series expansion of e raised to minus x. Okay, that's a homework for you. Try to find the Maclaurin series expansion of e raised to minus x. So similarly, you will have quantities like this. F of x will be e raised to minus x. F dash of x will be e raised to x into e raised to minus x into minus 1. Okay, f double dash of x will be e raised to minus x into, again it will be positive 1. Okay, it will be going like this. Okay, so in that case, if you try it out, you will be getting the expansion as, in place of x you have minus x. So it will be simply be 1 minus x plus x square by 2 factorial minus x cube by 3 factorial plus etc. Because in place of x there you will have minus x. So if you know the expansion of e raised to x, you can do a variety of problems like e raised to minus x. If I ask you what is the expansion of e raised to x, without doing this itself you can say, okay, just for in the place of x you have a 2x. So what will be the expansion here? Can you just guess that? It will be simply 1 plus, in place of x you have 2x, so 2x plus 2x the whole square by 2 factorial plus 2x the whole cube by 3 factorial plus etc. So many problems will be simplifying in this way itself if you know some standard expansions like e raised to x, sin x, cos x etc. So this is just to give you an idea. Okay, so I hope it is clear how to find the Maclaurin series expansion. So from that we will do the next problem, which is nothing but sin x. Okay, so please try to do this problem by yourself. So what is given to you? First write down the expansion. In every problem write down the expansion, which is f of x is equal to f of 0 plus x into f dash of 0 plus again x square by 2 factorial into f double dash of 0, okay, plus etc. Okay, now if you do the problems, now tell me, so how will you find it out? So here f of x is actually sin x. Okay, so what is f of 0? F of 0 is sin 0, which is again 0, right? Okay, what is f dash of x? F dash of x is cos x. What is f dash of 0? F dash of x 0 is cos 0, which is again 1. Okay, and what is f double dash of x? F double dash of x is actually minus sin x. So what is f double dash of 0? It is minus sin 0, which is again 0. And what is f triple dash of x? F triple dash of x is minus cos x. What is f triple dash of 0? It is minus cos 0, which is again minus 1. Okay, now can you guess the pattern? F fourth power would be, actually f fourth power would be again simply sin x. So f fourth power would be, it will be sin 0, which will be again 0, and f fifth power would be, can you guess it? F fifth power again it will be repeated, so it is cos x only. So it is f fifth power of 0 would be again 1. So what will be the pattern here? So it will be, your f of 0 is 0, so your sin x value is, so just substitute these values, f of 0 is 0, again f dash of 0 is 1, so we will be getting x. Okay, so f dash of 0 is 1 plus x square by 2 factorial, next term f by into f double dash of 0, it is 0, so you will be getting 0 here. Okay, if you take the third term, which is x cube by 3 factorial, you will have a negative power here, so it is x minus x cube by 3 factorial. Okay, now what is the next term? F fourth power is 0, fifth power is again 1. Okay, so it is plus x raised to 5 by 5 factorial. Okay, now can you guess the next term? It will be simply x raised 7 by 7 factorial. So this is standard expansion. What is the expansion of sin x? I am writing it again, x minus x cube by 3 factorial plus x raised to 5 by 5 factorial minus x raised to 7 by 7 factorial plus x raised to 9 by 9 factorial plus etc. So in the examination, if you ask, you can stop it with x raised to 5 by 5 factorial. Okay, so x cube by 3 factorial plus etc. Okay, so this is the expansion of sin x. Now can you give me the expansion of sin 2x? So it will be, in place of x I have 2x, so it is 2x minus 2x the whole cube by 3 factorial plus 2x the whole raised to 5 by 5 factorial plus etc. So if you want, you can check it out, just do it again if you want. So this is the expansion of sin 2x. Okay, similarly I am giving a new formula, what will be the expansion of cos x? Okay, that's the next formula for you. What is the expansion of cos x? So please try to do it by yourself. I will write the expansion here if you want. It is nothing but 1 minus x square by 2 factorial plus x raised to 4 by 5 factorial minus x raised to 6 by 6 factorial etc. Okay, so how did I write here? Here basically you will have only even powers of x which are alternating. In the case of sin x, it will have odd powers of x, which is nothing but x minus x cubed by 3 factorial plus x raised to 5 by 5 factorial. So this is the way you will remember this thing. Okay, and e raised to x will have all the powers of x, which is 1 plus x square by 2 factorial plus x raised to 4 by 4 factorial plus etc. Okay, I hope it is clear. Okay, similarly next, so I hope it is clear how to expand as a Maclaurin series. Okay, now let us look at this as another function, which is 1 by 1 minus x. Okay, so please try to do it by yourself. What is your f of x? The value of f of x is f of 0 plus again x into f dash of 0 plus x square by 2 factorial into f double dash of 0 plus etc. Okay, we need a 5 or 3 terms. Let us try to do it. So your f of x is 1 by 1 minus x, or it is, if I want, I can write simply as 1 minus x raised to minus 1 for finding the derivatives easily in easier way. So what is your f of 0? F of 0 is nothing but 1. Okay, and what is your f dash of x? Your f dash of x is actually, so this is of the form 1 plus x raised to n, so it is minus 1 minus x raised to minus 2 into minus 1. Okay, to balance this 1 minus x using the chain rule, you will have a factor of minus 1 there also. Okay, so this is actually 1 minus x raised to minus 2 only. So your f dash of 0 is again 1. Okay, what is your f double dash of x? F dash of x, double dash of x will be minus 2 into 1 minus x raised to minus 3 into minus 1. So it is actually 2 into 1 minus x raised to minus 3. So your f double dash of 0 would be 2. Similarly, what is your f triple dash of x? Again, 2 factors there. So 2 into minus 3 into 1 minus x raised to minus 4, okay, into minus 1. Again, you will be getting this as 2 into 3 into 1 into 1 minus x raised to minus 4. Therefore, your f triple dash of 0 will be, if f triple dash of 0 will be 2 into 3 into 1, or in other words 3 factorial. F double dash of 0 is actually 2, it is actually 2 factorial. Your f dash of 0 is 1, actually it is 1 factorial. Again, if you take f raised to 4 of x, you will have a factor of 4 also there. So f raised to 4 of x would be again 4 factorial factor would be coming out there. Okay, remember that. So if you have understood this, so the expansion would be your f of s0 is 1 plus x into f dash of 0 is again 1 plus x square by 2 factorial into f double dash of 0 is again 2 factorial plus x cube by 3 factorial into f triple dash of 0 is 3 factorial. Okay, so you will be getting it as 1 plus x square plus x cube. Okay, so it's a standard expansion. So 1 by 1 minus x is 1 plus x square plus x cube plus etc. Okay, this is very standard notation which we will be using later also. Already you know this is actually your geometric series only. If you look closely, this is actually geometric series 1 plus x square plus etc., which has the sum 1 by 1 minus x. Okay, what if I need the expansion for 1 by 1 plus x? Okay, so in place of x it is minus x, so you can easily deduce from this expansion itself if you want. It will be simply be 1 minus x plus x square minus x cube plus etc., because in place of x I have minus x here. Okay, so that is way. So similarly you can guess the expansion of 1 by 1 plus 2x, 1 by 1 minus 2x etc. using this also, or else you can apply the formula directly also. So applying the formula directly would require some work there, but it could be easily simplified if you know some standard notations. Okay, so these are some standard expansions which are done. Okay, so in the next session we will be doing more extensive problems, so there we will be using these applications there. Okay, so moving forward, let us now discuss some Taylor series also. So usually they will ask Maclaurin series. Taylor series is rare, but still it is easy. The approach is just the same only. Now let us expand this 1 by x about x is equal to 1. So how will you expand it? Okay, so if you want a Taylor series, remember I need to expand this about x is equal to 1, because I need, so my power should be, my expansion should have powers of x minus 1. Always remember that your expansion should have always the powers of x minus 1, not the powers of x. Okay, so there it is explicitly told you to expand it about x is equal to 1. Okay, so write down the expansion. So what is f of x is equal to f of 1, just look back the expansion, f of 1 plus again f dash of 1 by 1 factorial into x minus 1 plus f double dash of 1 by 2 factorial into x minus 1 the whole square plus f triple dash of 1 by 3 factorial into x minus 1 the whole cube plus etc. So this is expansion. So using the same approach you can do this also. Okay, so your f of x is 1 by x, so your f of 1 is 1, and what is your f dash of x? F dash of x is again 1 by x, it is minus 1 by x square, so f dash of 1 is actually minus 1. Okay, and what is your f double dash of x? F double dash of x is actually, this is actually, f dash of x is actually minus x raised to minus 2. So when you multiply, so when you take the derivative, you will have minus 1 into minus 2 into x raised to minus 3. So it is actually 1 into 2 into x raised to minus 3. So f double dash of 1 would be simply be, f double dash of 1 will simply be 2 factorial into 2 factorial. Okay, and again, so f dash of 1 is minus 1, f double dash is again 2 factorial. Can you guess what is f triple dash of x? So your f triple dash of x is 1, so this is f double dash 1 into 2 into x raised to minus 3. So f triple dash of x would be 1 into 2 into minus 3 into x raised to minus 4. Okay, so basically it is minus 3 factorial into x raised to minus 4. Okay, so if f triple dash of 1 would be again minus 3 factorial. So you can see that alternatively the signs are changing. Okay, so here it was my f dash of 1, it was minus 1, f double dash of 1, it was 2 factorial, f triple dash of 1, it was minus 3 factorial, f 4 dash of 1 would be 4 factorial. So it will be going on like this. So what is the expansion now? So it is nothing but f dash of x, f of x is equal to f of 1 is 1, f dash of 1 is minus 1, minus x minus 1, okay, plus f dash of 1, f double dash of 2. F double dash of 1 is x2 factorial, so it is plus x minus 1 the whole square, okay, minus x minus 1 the whole cube plus etc. Okay, so this is one way of expanding it, that's enough. Okay, so I hope it is clear how to expand the function as a Maclaurin series and Taylor series. Okay, now I will just give you another way also. It is not required for examination, but if you can understand that, it will be much easier. Okay, so remember, you need to know that this Taylor series expansion should be about x is equal to 1. Okay, this is an easy way, but if you don't understand, you can just leave it, but it's a very simple way. Okay, so that means I need to change this x into x minus 1 here. I need the powers of x minus 1 here. So I'll make a small tweak in the denominator, that is I'll write this as 1 by x minus 1 plus 1. Okay, 1 by x minus 1 plus 1, or simply it is 1 by 1 plus x minus 1. So it's same thing only. Okay, if you look at this, it's the same thing. Now I'll use this expansion of 1 by 1 plus x there. What is the expansion of 1 by 1 plus x? It is 1 minus x plus x square minus x cube plus etc. as I told you earlier. So this is of that form where you in place of your x you have x minus 1. So the expansion would be 1 minus x minus 1, okay, plus x minus 1 the whole square minus x minus 1 the whole cube plus etc. This is the same expansion which we got while using the formula directly. Okay, using that may also you can do. This is also another way. Okay, so by using the standard transformation itself, you can write it down. Okay, it's not necessary for you to study this method. I'm telling you there are many ways to expand as a Taylor series. All the methods would be just the same only, because there's a result that the Taylor series expansion is always unique. Okay, using that result, in whichever way you expand, always you will be getting the same result only. That is why I'm doing this, but it is not required for you now. This is just for your understanding that I'm telling you. Okay, so next I'll give you homework also. Try to expand cos x about x is equal to pi by 2. That means you should get the cos x powers of x minus pi by 2. Okay, so same thing only. Write down the formula. What's the formula? Formula is f of x is equal to f of pi by 2 plus again x minus pi by 2 into f dash of pi by 2. Okay, plus x minus pi by 2 the whole square by 2 factorial into f double dash of pi by 2 plus etc. Okay, so your f of x is cos x. Okay, so what is your f of pi by 2? F of pi by 2 is cos pi by 2, which is again 0. And what is your f dash of x? F dash of x is minus sin x. And what is f dash of pi by 2? F dash of pi by 2 is minus sin pi by 2, which is minus 1. Okay, again f double dash of x would be minus cos x, and f double dash of pi by 2 would be minus 0, so it is 0. And what is f triple dash of pi by 2? Again, if you remember the pattern, f triple dash of pi by 2, f triple dash of x would be sin x, so f triple dash of pi by 2 will be sin pi by 2, which is again 1. So the expansion would be f of pi by 2 is 0, again x minus pi by 2 into x minus pi by 2, f dash of pi by 2 is, okay, f dash of pi by 2 here, okay, sorry. Okay, so x minus pi by 2 f dash of pi by 2 is minus 1 minus x minus pi by 2, again x minus pi by 2 the whole square by 2 factor into f double dash of pi by 2 is again 0, again f triple dash of pi by 2 is 1, so you'll have plus x minus pi by 2 the whole cube by 3 factorial. Okay, so it will go on like this. So you just write 2 or 3 terms here, just form a fourth power, a fifth power also, because your fourth power would be 0 again. So again you will be getting like x minus pi by 2 the whole raised to 5 by 5 factorial plus etc. Okay, so this is one way of doing it. You can also do it in the other way also, which I told you. If you can guess it, okay, just try to guess it using cos x expansion, so you can write it down. Okay, it's very simple, because remember I need the powers about x minus pi by 2. This is not required for your examination. If you want, you can always use the direct method. That's the most easiest method to understand or reproduce. Okay, this is actually a shortcut method if you know the standard expansions. Okay, so what I'll do is that I'll write cos x as cos x minus pi by 2 plus pi by 2. Okay, so cos x minus pi by 2 plus pi by 2. What is cos pi by 2 plus theta? It is minus sin theta. So it is minus cos x minus sin x minus pi by 2. Okay, and you know the expansion of sin pi by 2. Sin x, it is actually odd powers. So it is sin x expansion is x minus x cube by 3 factorial plus x raised to 5 by 5 factorial. So here it is, instead of x you have x minus pi by 2, so it is x minus pi by 2 minus x minus pi by 2 the whole cube by 3 factorial plus x minus pi by 2 the whole raised to 5 by 5 factorial plus etc. But there is a factor of minus here, so effectively you will be getting this expansion. Okay, so that is an easier way if you can remember. For examination purpose, you can use the direct method itself. That's the okay. So this is the easiest to understand and apply. The direct method is the easiest to understand and apply. These are actually shortcut methods which will help you save some computation. That's it. Okay, even if you write both methods also, you will be getting the full marks. Okay, so moving forward, now let us briefly touch upon the problems of radius of convergence and also the interval of convergence also. This is not actually there in your syllabus, but once or twice it has been asked in the examination, so I'll just touch upon that also. In the syllabus it is not mentioned for you, but try, it's very easy to understand. Okay, so they'll give you a power series and they ask you to find the radius of convergence, or they'll ask you to find the interval of convergence. Okay, so basically the problem is you need to find the condition of convergence there. Okay, so basically your series would be a variable term series, as I told you, and it will, when you try to find out the basic convergence, you will always be getting condition on x there. Okay, so you know, when you try to find the convergence of infinite series, you will be using various tests like comparison test, ratio test, root test, etc. Most probably you will be using ratio test. So when you use the ratio test, you know that the series will converge if uk plus 1 by uk is less than 1. Okay, so when you apply this condition there, you will be getting a condition on x, and that is how you find the interval of convergence. Once you find the interval of convergence, half of that length of that interval would be the radius of convergence. So you will be using this result here. I will be giving you an infinite series. You look at this test, the ratio test, find out. So if you have an infinite series, use the ratio test to find the whether the series is convergent or not. But since the terms would contain x, you will always get a condition on this x. Okay, so that is how you obtain the condition for convergence using this x. So let us do some problems so that you will understand it better. Okay, so this is the function here. So here, to find the interval of convergence, we apply the ratio test for absolute convergence to test the condition of convergence. What's the ratio test? It is nothing but uk plus 1 by uk. You look at limit k tends to infinity, uk plus 1 by uk. You are using absolute convergence because you don't know whether these terms are positive or negative. So you know, as you have studied in absolute convergence, if the series is absolutely convergent, the given series also would be convergent. So you will be looking at this quantity. Okay, so we have studied this concept in absolute convergence there. Essentially it is the ratio test in the positive term series only. You are considering the terms as positive, that's it. Okay, so it is uk plus 1 by uk, you will be taking it, and now if this limit is less than 1, we will say that the series is convergent. If it is greater than 1, the series is divergent. For equal to 1, we don't know, so we will be trying to do that now. Okay, so we will be using that test here. Okay, let us do some problems here. Okay, so these are some cases of convergence here. Just for illustration, I told you sometimes the series may be convergent only at this point x naught. Okay, so in that case, your radius of convergence is 0. Sometimes the series may be convergent in the entire real line. In that case, your radius of convergence would be infinity. Okay, sometimes your series would be, in other terms, your series would be convergent in an interval around this x naught. So that time your radius of convergence would be r. This is just for an illustration only. Let us try to do some problems. Okay, so let us now look at this problem here. Find the interval and radius of convergence of the following series. Okay, so forget about power series or everything or any that matter. Suppose I am giving you a series like this and asking you to find out the interval condition for convergence. So what will you do? Write down the series. It is 1 plus x square plus etc. Okay, forget about everything about power series. This is a general series given to you. How will you test for convergence? I don't know whether this is a positive term series, negative term series, alternate series or nothing. So what I will do, I just look at the absolute powers of the terms. So I look at uk plus 1 by uk. Okay, what is uk plus 1? It is x raised to k plus 1 by x raised to k. Okay, so I look at this one. So limit k tends, I look at the absolute term test. It is limit k tends to infinity, uk plus 1 uk. It is limit k tends to infinity, x raised to k plus 1 by x raised to k. So it is nothing but, so limit k tends to infinity mod x I will be getting. Okay, so this is value is actually equal to mod x. Okay, because I am taking positive terms here. Okay, so mod of x raised to k plus 1 by x raised to k, which is nothing but mod x, and I know that this limit, this series will be convergent if this limit is less than 1. Okay, and divergent if this limit is greater than 1. So what I will say? So I will say that this series is convergent if mod x is less than 1. Okay. So this is your interval of convergence, nothing new is there. Just using the usual notation of that absolute convergence. I'm just taking the series and looking at uk plus 1 by uk. I'll be getting the limit as mod x, and I know that that series is convergent if that limit is less than 1. Okay, so this is the interval of convergence. And now can you guess the radius of convergence? You know that this interval of convergence has total length minus 2 because it is minus 1 less than x less than 1. So what is the radius of convergence? Radius of convergence is nothing but 1. Okay, and can you tell about the endpoints here? What happens when your x is equal to 1? What happens when your x, because you know that the power series is always convergent in an interval around this x is equal to 0, and we don't know anything about the endpoints. So what if your x is equal to 1? When your x is equal to 1, your series becomes 1 plus 1 plus etc. So it is going to infinity because your terms are 1 plus 1 plus 1 plus etc. So if x is equal to 1, the series is not convergent. And what if your x is minus 1? Then in that case your series would be 1 minus 1 plus 1 minus 1 plus 1 minus 1 also. So in that case also the series is not convergent because it is oscillating. Therefore I can say that this series converges if minus 1 strictly less than x less than 1, and the radius of the convergence of the series is 1. Okay, so what concepts have you used? Have you used any concepts of power series here? We have not used any concepts of power series here. You are just using the infinite series only. But since this terms contained x, you got a condition in terms of x. That is what is required. You got a condition in terms of x, which is your mod x should be less than 1. Okay, so let us try to do one more problem so that you will understand this much better. Okay, look at this series here, x raised to k by k factorial. Okay, forget about power series and everything. Your series is 1 plus x square by 2 factorial plus etc. So look at uk plus 1 by uk. What is your uk plus 1? Your uk plus 1 is x raised to k plus 1 by k plus 1 factorial. What is your uk? Your uk is x raised to k by k factorial. So when you take uk plus 1 by uk, it will be x raised to k plus 1 by k plus 1 factorial into x raised to k into k factorial. Okay, I am taking the modulus because we are using the absolute convergence test here. Actually it's the same thing only, but in order to be more rigorous I am using the absolute terms here. So I will be getting this as your k plus 1 and this x raised to k will be cancelled out. Your k factorial and k plus 1 will be factored out. So you will be getting just modulus of x by k plus 1. Okay, I hope it is clear because k factorial and k plus 1 factorial is 1 into 2 into 3 etc. k into k plus 1. So this is modulus of x by k plus 1. And what is limit k tends to infinity modulus of uk plus 1 by uk? What will be the value? It will simply be modulus of x plus limit k tends to infinity modulus of x by k plus 1. Here x would be a fixed value, I don't know. So for some values of x it will be fixed. Suppose your x is 10, x it is fixed there. But here the value which is varying is actually k. This denominator is going to infinity and x is being fixed there. So what would be the limit value? Whatever be the value of x, this denominator is going to infinity only. So what will be the value of the limit? The limit would be 0. So whatever be the real value of x, your denominator is going to infinity here because k is going to infinity. So the overall limit value would be 0 only. Okay, so for each problem your x would be fixed once. For one series your x would be 1, for another series your x may be 100, but your x is fixed there. But your k is varying and your denominator k is going to infinity, therefore the limit value would be 0. That means this limit is less than 1, therefore it will converge for all values of x. So it will converge for all values of x. What does that mean? That means your interval of convergence is just your real line r. So the interval of convergence would be your real line r, and what will be the radius of convergence? The length of r is infinity, therefore the radius of convergence would also be infinity. Okay, let us do one more problem. If you are not convinced, let us look at this problem here. Okay, try to do it by yourself. You will be looking at uk plus 1. uk plus 1 is minus 1 raised to k plus 1 by x raised to k plus 1 by 3 raised to k plus 1 into k plus 1 plus 1, so it is k plus 2. Okay, what is your uk plus uk? It is minus 1 raised to k x raised to k by 3 raised to k into k plus 1. Okay, so what is your modulus of uk plus 1 by uk? So it is nothing but modulus of, you don't need to consider minus 1 now. So it is x raised to k plus 1 by 3 raised to k plus 1. Do it with me only, then you will understand. k plus 2 into x raised to k into 3 raised to k into k plus 1. Okay, so this is your modulus of uk plus 1 by uk. You can simplify it if you want. So here it will be modulus of x by 3 into k plus 1 by k plus 2. Okay, now apply limit k tends to infinity. So when you apply limit k tends to infinity, what will you get? This quantity, the numerator, I can take k outside, so I will be getting it as limit k tends to infinity modulus of x by 3 into k into 1 plus 1 by k divided by k into 1 plus 2 by k. Your k get cancelled out. So when you apply k tends to infinity, you will be getting the limiting value as modulus of x by 3. Okay, now this is the limit value. Therefore, this series is convergent if mod x by 3 is less than 1 and divergent if mod x by 3 is greater than 1, or I will be getting the interval of convergence as mod x is less than 3. Okay, so the series would be convergent if mod x is less than 3 and the series would be divergent if mod x is greater than 3. And similarly, what's the radius of convergence? Your interval is minus 3 less than x less than 3 and the radius of convergence would be basically 3. Okay, so the total length is 6. Okay, now can I just think of the endpoints here? What happens if your x is 3? What happens if your x is 3? That's a homework for you. You will be getting the series as 3 raised to k by 3 raised to k minus 1 raised to k by. So if your x is 3, you will be getting the series as minus 1 by k plus 1 sigma minus 1 raised to k by k plus 1, which is your alternating harmonic series. Okay, so when your x is 3, you will be getting the series as alternating harmonic series, which is convergent. Your alternating harmonic series is 1 minus 1 by 2 plus 1 by 3. We have discussed the series before using Leibniz test. This is convergent. Okay, so when x is equal to 3, the series is convergent. What happens when your x is equal to minus 3? So when your x is equal to minus 3, what will happen? Your series, this x raised to k will be minus 3 raised to k, so it will be minus 1 raised to k into 3 raised to k only. Okay, so ultimately you will be getting here at minus 1 raised to k into minus 1 raised to k into 3 raised to k. So this minus 1 raised to 2k will be getting. So simply it will become sigma 1 by k plus 1. Okay, just think. Your x raised to k is minus 1 raised to k into 3 raised to k. So it will be minus 1 raised to 2k, which is always 1. So simply it will become 3 raised to k in the numerator divided by 3 raised to k in the denominator by k plus 1. So it is simply the series sigma 1 by k plus 1, which is 1 plus 1 by 2 plus 1 by 3, which is the harmonic series, p series with p is equal to 1. Therefore, what will happen? This series is divergent. Okay, so these are some ideas. Already you know all these concepts only thing you are just employing it in the terms of this power series. Okay, there is no new concepts here, only the previous concepts you are using. Only thing is that you will be getting a new condition based on x. So this series, the interval of convergence of this series is actually, if I write it clearly, it is minus 3 less than x less than or equal to 3. Okay, always remember to write the find the endpoints also. I am telling you once again, the radius of convergence and interval of convergence is not there in the syllabus, but once or twice the questions were asked. That is why I am discussing it. No new concepts are there. It's very simple. Okay, just try to apply the earlier concepts into this one. That's it. Okay, so try to do this problems also here. So if you want, I will do this problem also. You can do it yourself also. So your UK plus 1 here. In this is a different series now. It's basically a power series about x is equal to 5. So what will you do? Look at UK plus 1. Your UK plus 1 is x minus 5 raised to k plus 1 by k plus 1 square. Your UK is x minus 5 raised to k into k square. Okay, so if you take UK plus 1, you will be getting like this, UK plus 1 by UK. Just do it by yourself. So this will be getting it as x minus 5 by x minus 5 into k square by k plus 1 the whole square. Okay, so when you apply limit k tends to infinity, what will you get? When limit k tends to infinity, this will simply become x minus 5 into k square divided by k square into 1 plus 1 by k the whole square. So when you apply limit k tends to infinity, this quantity will become simply modulus of x minus 5. So when k goes to infinity, this 1 by k will go to 0. So this will be simply be modulus of x minus 5, and you know that this series will converge if mod x minus 5 is less than 1. That means your interval of convergence is this one, or simply if you write it clearly, it will simply become minus 1 less than x minus 5 less than 1, or it is 4 less than x less than 6, 4 less than x less than 6. Okay, and your interval of convergence is radius of convergence. What's your radius of convergence? Cannot guess. Here basically interval length is 2, so the radius of convergence is basically 1. Okay, so your radius of convergence is basically 1 here. Okay, and remember one other thing also, try to find out what will happen when your x is equal to 4. Just think, and what will happen when your x is equal to 6. Look at which series you will be getting here. Okay, just look at that also. So what will happen when you get x is equal to 4, x is equal to 6. When x is equal to 4, you will be getting the series as minus 1 raised to k by k square. Okay, so basically it is minus 1 raised to k by k square. This is convergent by Leibniz test. We have seen it before. Just look at the series, try to find it here by yourself. When x is equal to 6 also, you will be getting it as simply 1 by k square. Okay, that is the p series with p is equal to 2. That is also will be convergent. So your interval of convergence would be simply this one. Okay, so please try to do it by yourself. Okay, so that's it. So I hope it is clear. Okay, we will do more problems in the next session also. Okay, thank you.